What is up, mathletes? So we are live, and I'm here answering your questions related to homework. All right, so again, put them in the chat or email them to me, and I will get your questions answered. All right, so I'm going off of the list. I've ordered them, and someone had a question from homework 8, number 1. All right, so let me walk you through this. And I'll use the explanation to kind of help you out because sometimes the explanation itself um, isn't that helpful. So let me give you some more context, some more information behind the scenes. All right, so notice you have three functions here. All right, you have three functions. And what they're going to do is they tell us to evaluate. What I like to think of is see this number they give you? You're going to be plugging them in, that number in to each one of these functions, f and g. So you're going to plug in the 3 into f, you're going to get an answer. You're going to plug in that same number 3 into g, you're going to get an answer. And then, see that subtraction? That tells us that we're going to subtract the two answers. That's all that's happening. All right. So I plug it into f. Notice the work down here. So negative 2 times 3. All right, that's what you see there is negative 6. And then g, you're going to plug in the negative 3 right there. Or sorry, the 3. And then you get 3 plus 6 is 9. All right, and you take the absolute value of 9, which is 9. And that minus, you just keep dropping it like it's hot. Bam, bam. So at the end, you're just left with negative 6 minus 9, which gives you negative 15. And so that's our answer for this problem right here. All right. So again, what did we do? Whatever number they gave you in parentheses here, that's your input. That's what you're plugging in. Where do you plug it in? In this case, they say plug it into F, which is right here, and plug it into G, which is right here. Notice there's no H. So this one, we don't even have to worry about. All right, making sense? Cool. So let's jump to question number 2. All right. So this is the same thing. I'm going to skip over this because it's the same exact thing. But let me just quickly show you how all you're doing is plugging it into the 1 into this time G, which is right here. So they plugged in the 1 right there. And then they plugged in the 1 into H, which is right here, right? And then you just do the math. 1 minus 2 is negative 1. You have a negative and a negative. That's going to turn into a positive. So this turns into a plus. And then the absolute value of negative 3 is positive 3. All right. So again, that's all you're doing for the first couple problems. All right. This one's a little different. So make sure you take notes here. And they have a multiplication sign, right? You got a multiplication sign. That's what that little dot means. Just in case you didn't know, now you know. All right. So you better tell somebody. But the idea is the same exact thing. What are you plugging into F? Boom, you're plugging in this negative 1. What are you plugging into G? You're plugging in negative 1. So make sure you stop this video and you write down all these details because right now it's going to make sense. 2 hours from now, you're going to forget it. So what I want you to do is, boom, copy down these notes and then you try your problem, right? And it's going to help you this way. So you take notes, do your problem. Take notes, do your problem. All right. So this time, after you go ahead and plug in your values and you do whatever it says, then you multiply your two answers. So at the end, you multiply 7 times 5, you get 35. All right. So it's practically the same thing we've been doing before. This one, same exact thing. Where you see H, you're going to plug in 3. So 3 minus 2 is 1. 1 divided by 1. This is going to give you 1. And then where you see G, you're going to plug in 3. 3 plus 4 is 7. Absolute value is 7 is 7. So you end up with 7 times 1. Your answer is going to be 7 for this one. But again, the idea stays exactly the same. So let's see. This one, all you're doing is plugging in negative 6 for G. All right, right here you can plug in negative 6. That'll be 0. For H, you plug in negative 6. This is going to give you negative 13 on the bottom. So notice on this one, you're going to end up with a fraction. So let me just show you. Right? You end up with that negative 13, like I said. And 0 minus 1 over 13 is just negative 1 over 13. And this one had a plus sign in the middle. So that's why you went ahead and you added those two answers. All right, let's jump into a harder one. Let me fast forward here. All right, this one, it might seem harder, but it's the same exact thing. The only difference is, you see how you have a division? That means your answer for G is gonna be on top when you plug in 3. So let's say you get 9, that's gonna be on top. And when I plug in 3 for this one, for F, you're gonna get -9. So you're gonna get 9 over -9, and so we should get -1 for our answer. So just so you could see what that looks like, right? We plug in 3 into for G, you plug in 3 for F, you do all the work, right? And then you end up with that -1. So division makes no difference. All right. Some people might get scared, like, oh shoot, this has a square root and squared. It's the same thing, right? The only thing is, now you're gonna have to take square roots of numbers. No big deal. All right. So here in this case, what I want you to notice is they don't give you a number to plug in. But what they do want you to do is find the domain. We've talked about the domain in the past. All right. So what I want you to notice, write this down. We've talked about it before, is when you have a square root, what you want to do is you set this square root to be greater than or equal to 0, right? You want this to be greater than or equal to 0. Let me write that down. All right, we've done it in the past. I don't have to worry about anything that's not in the domain. So let's see, let me get my little annotation here. So whatever's inside the square root, right? Because this is what I'm focused on right here. That's my R and my Q. But my Q is the one with the square root. So whatever's inside my square root, if you ever see a square root, set this to be greater than or equal to 0. Then when I solve, add x, 5 has to be greater than x. Or you could rewrite this and make the x first. So 5 has to be greater than x. So if I ever change these, right, this symbol has to turn around. Oops, that should be a 5. So notice I switch these. So whenever I switch these, this sign also has to change directions. So just make sure this little, think of it like a little arrow, has to always point to the same value. So right now that arrow is pointing to the x. So when I flip sides, excuse me, it still has to point to the x. All right. So x is less than or equal to 5. All right. So how do I write that? Well, to help you, one thing I could do is I could do a number line. And if I have 5 and I have a closed circle, and the reason it's a closed circle, remember, is because you have an equal sign, right? So you have a closed circle, and what that means is it's going to be everything to the left, right? So what numbers are to the left? Well, that goes on forever, ever. So it's negative infinity all the way until this number right here, which was 5. Because it's a closed circle, right? You're including 5. That's why we put that bracket there. So that's where this comes from. So this is the domain. And when we're looking at the domain, we're looking at what numbers am I allowed to plug in, right? That's really the big question. All right. So let me clear this. You copy it down, press pause, do what you need to. Put this on rewind. But again, just make sure it makes sense. Don't forget about office hours. So look at your syllabus. We got some good office hours for you guys. All right. This one, it might seem tricky. It gets a lot of people because there's fractions. And look, it says S on top, T at the bottom. All right. So all you're doing is you're going to have a fraction divided by a fraction. All right. So S, right, is right here. And then T is down here. All right. So I'm going to tell you kind of what's going on here. So the first thing, whenever you have a fraction divided by a fraction, write this down in case you forgot. Let me give you numbers so you know what I'm talking about. Let's pretend, I'm just making this up, so don't worry about where is this coming from. Let's pretend you have 2/3 divided by 5/7. Okay, according to our rules from back in the day, this is the same thing as 2/3. So there's your numerator times the reciprocal, the flip of the denominator. So 7/5. So that's all that's happening over here, right? This top stays the same. So it's still x over 5, x squared minus 49. But now it's going to be times, we got to flip this bad boy. So now the 5 minus x goes on top, and the x minus 7 goes on the bottom. All right, so notice that got flipped. And so this is what we're left with. And then now the next step, you're going to see some cancellation. All right, so go ahead, press pause, copy that down so I could erase this and move to the next piece down here. All right, so now I want to factor this. This is a difference of squares. So whenever both of these are perfect squares, I have a video to help you with factoring. If you want it, let me know. It's in my YouTube channel. But basically a shortcut, I'll take the square root of x squared, it's x. Take the square root of 49, 7. So we factor this, and then what I also like to do is some people are like, how did they go from here to here? See how x is first here, but x is second over here? So what I like to do, let me write this down, is I'm going to change this. Let me let you guys know. I'm going to pull out a -1. And that's called factoring, right? So I'm going to factor out a -1. When you factor out a -1, what happens is your signs change. So that negative x now becomes a positive x. That positive 5 now becomes a -5. And if I were to multiply this back in, that gives me the original, right? If I multiply back in, my x becomes negative. If I multiply the -1 back in, that 5 becomes positive. All right. And so this is what I get. So I end up with I end up with x minus 5 times -1 x minus 5. Look how many x minus 5s I have. I have 2 of them. That's where that number 2 comes from, okay? It's squared because there's 2 copies. I shouldn't write the times. It looks like an x. And then this -1 just goes in front. So that's where that is. All right. So in case you were wondering, how did they go from here to here? That's what happened. How many x minus 7s do I have? I have 2. And I have 1 x plus 7. All right. So now that we've simplified this, how do we get to the domain? All right. So again, make sure you write all these steps. This is a lot of work, right? It's a lot of work. This isn't easy. So that's why you got to start early and grind hard. All right. So what we do with each one of our factors, so each one of these mother factors, we're going to set it equal to 0, because if you remember from our last lesson in class, you can never, ever, 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 ever divide by 0. So I'm going to add 7 here. I'm going to add 7 here. So you get x equals 7. I'm going to subtract 7 here, subtract 7 here. So x can never equal -7, and x can never equal +7. So if I have a number line, what I'm going to have is that -7 on my number line. I'm going to have an open circle, because that could never be one of my values that I plug in. I'm also going to have an open circle at 7. So all the numbers are allowed except those 2. So in my graph, everything else would be shaded in. So what does this look like? Well, I start from -infinity. So I have the parentheses all the way until -7. Open parentheses. Whenever I have a gap, I put a U, right? I start back up at -7, but I'm not including it. So that's why I'm using open parentheses. If it was a closed circle, right, I'll use brackets. I'll change this problem. We'll talk about that later. All the way to 7. Again, I have an open circle, parentheses. And I put a U because I still continue going. And I start back up at 7, all the way to infinity. And so that's how they end up with that domain right there. All right, if my 2 numbers were 9 and -8, and this would be -8, -8, and this would be 9, 9, and 9, right? All right, Matthews, be honest, give me some feedback, because if this is helpful, I want to keep doing it for you. All right, but I need you guys to let me know email me, put it on Canvas. Let me know if this is helpful. If you want me to continue doing this, all right. Work hard. I'll continue being here to support you. All right, Matthews. Talk to you later.